Hi, Dr. Ko. I'm Wei Mien, metric number 161081. Today, I will be presenting my project on resume screening predictions using classifications algorithm. Resume screening is a crucial step in hiring, yet manual screening is time-consuming, biased, and inconsistent. Even with ATS, candidates might be unfairly filtered out due to keyword mismatching. To solve this, I applied machine learning classifications algorithms to automate and improve the efficiencies and fairness of screenings. This study's objective is to examine the efficiencies and occurrences of different algorithms in predictive higher decisions based on the resume data. The significance of these studies is to improve the recruitment efficiencies and fairness. Next, we move on to the literature review. There are three types of machine learnings, which are supervised machine learning, unsupervised machine learning, and reinforcement machine learnings. In these studies, we will focus on supervised machine learning. Supervised machine learning is a training models using labels datasets to make predictions. Classifications is one of the supervised machine learning techniques that involve categorizing data into discrete class. Studies also shows that machine learning could improve recruitment efficiencies. Another study shows that decision tree, Bayes, and KNN have been tested in HR systems, often improving accuracies and reduce bias in hiring decisions. In these studies, the methodologies are structured into several key steps. First, for data collections, I used a dataset for cargoes that contain 1,000 resume informations and recruiter decisions labels as hires or rejects. During data pre-processing, I explore the structures and types of data. In the data cleaning stage, I remove basic value in certifications columns and use interquartile range methods to identify and remove outliers such as experience, salary expectations, and project count. For encoding, I use label encodings to convert categorical variables such as skills, educations, certifications, and job role into numerical data. Next, I apply feature scaling using standard scalars to normalize values. In modeling space, I train six classifications algorithms which are logis- logistic regressions, decision tree, random forest, support vector machines, Bayes, and neighbor. Lastly, I evaluate model performance using several metrics. The confusion metric was used to visualize true positive, false positive, true negative, negative. Occurrences are used to measure overall correctness of models. Predictions indicates that how many predicted hires are actually correct. Recall shows that how many actual hires are successfully identified. And F1 score balance both precision and recall score, especially useful when the datasets are imbalanced. After removing the missing values, the datasets were reduced to 726 samples, which 580 are for training purpose and 146 samples are for testing purpose. The confusion matrix shows that logistic regressions perform best overall. It identifies 126 qualified candidates for hirings, only one forced hirings, and missed three qualified candidates. The decision avoid any first hirings which are excellent, but it means eight qualified candidates. It has 121 true positive and 17 correct rejections. For random forest, is have a balanced performance with 125 correct hirings, 3 false rejections, and 4 false exception. Support Vento machines provide similar result with random forest and KNN, which are 125 correct hirings, 2 false rejections, and 4 false hiring. KNNs identify 125 correct hirings and 15 proposed rejections, and 7 false rejections and 4 false hiring. NAFBEAR predicted 123 correct hirings but make the most false hiring with 6, while only missing 3 actual qualified candidates. In terms of accuracy, logical regressions leads with 97%, followed by support vector machines, which are 96%, and both decision trees and random forests achieve a high score that is 95%. Nefbe score 94%, and KNN was the lowest one, which are 92%. Classifications report highlights that logical regressions achieve the highest F1 score, especially for hiring decisions which are class 0. In retended that there is a most qualified candidates with lesser errors. On the other hand, KNN record the weakness performance in rejections accuracy, which is Class 1, indicates that it struggles to figure out unqualified candidates. Overall, logistic regression stand out as the most reliable and accuracy model. Next, we move on to the discussions. Among these algorithms, logistic regressions stand out the best, which are 139 correct predictions out of 146 classes. That is 126 true positive and 16 true negative is only 4 errors overall. In contrast, KNN has 135 correct predictions with 125 true positive and 10 true negative, but it made 11 errors, including 7 false rejections for qualified candidates. These comparisons highlights that logical regressions is not only accurate but more reliable, especially in correcting identified both suitable and unsuitable candidates. Looking at the precision recall and F1 score, logistic regressions again performs the strongest, especially in class 0, which are hiring. With highest F1 score, it means that it successfully identified qualified candidates with minimize false rejections of hirings. On the other hand, KNN has the weakness performance in class 1, which I reject, showing this it struggles to identify and filter out unqualified candidates. It could result in poor thing, poor hiring decisions and waste of HR resource. Although the result is promising, these studies have some limitations. First, the dataset is only includes 726 samples, which may reduce the model abilities to generalize to the real-world applications. Second, the models use only structured data and machine learning, so it cannot fully capture the complexities of resume content, especially text. To improve this, I recommend integrating natural language processing NLP to extract and analyze resume text with numerical data. Using larger and more device datasets and regularly update the models can also ensure the accuracy over the time. In conclusions, these studies demonstrate the machine learning algorithms can significantly improve the accuracies and efficiency of resume screenings. Amongst all models tested, logical regressions perform the best, showing the highest accuracy, precision, recall, and F1 score. It also have a lowest numbers of misclassifications, making it is the most reliable for identify both qualified and unqualified candidates. To future advance the system, future work should use largest real-world dataset and integrate natural language processing to analyze text-based resume content. Additionally, implementing continuous modules update can help adopt to the change of job markets demands and resume style, making automate screenings more fair, adaptive, and accuracy over the time. That's all for my presentations. Thank you.